Newton's three laws of motion are the foundation for classical physics. Yesterday, you learned a little bit about inertia and Newton's first law. Today, we're going to be looking a little bit closer at Newton's second law. Now, the first thing I want to do is just give you a quick review of Newton's law of inertia. This is the first law. And basically, it's made up of two parts. The first part states that an object at rest will remain at rest unless acted upon by an unbalanced force. The second part says that an object moving in a constant velocity will continue moving in a constant velocity unless acted upon by an unbalanced force. Some of the examples that you looked at yesterday for an object at rest will stay at rest is the flicking experiment where you could just get the quarter to drop straight into the glass. The other one is one example of the crash test dummies. When the car stops, the people keep going. With that in mind, you need to remember two key points. The first one is that inertia is very dependent on mass. As a matter of fact, the greater the mass of an object, the more inertia it has. So there's your summary of Newton's first law. Let's go ahead and move to Newton's second law. Newton's second law goes as follows. An object's acceleration depends on its mass and the net force acting on it. Hopefully acceleration sounds familiar. We already examined all of this before. We talked a little bit about forces, and here we're going to be pulling in mass. Newton's second law, all these words can be put into this one equation, where F is equal to force, M is equal to mass, and A is equal to acceleration. So force equals mass times acceleration. This is Newton's second law, and we're going to be looking at it closely today and seeing how we can use it mathematically to determine certain things. Now, this formula, force is equal to mass times acceleration. The thing that I kind of like about this is Newton's second law fits very nicely into the force triangle. This should be pretty similar to and familiar to the speed triangle. And essentially what happens with the force triangle is that you can take force, you can calculate your unknown by covering it up, and you can see that it's mass times acceleration. Now this is a little bit different than the speed triangle in that there are very specific units that you need to use. In speed, we had lots of different units of measurement, lots of different units of time. With Newton's second law, they're very specific. First of all, force is measured in newtons. The second thing is mass. Mass has to be measured in kilograms. So if you're given a problem and it's not in kilograms, you may have to do a conversion. The next thing is acceleration. Acceleration will be measured in meters per second squared. So now that you have that in mind, what I'd like to do is go back down to this force triangle. And if you recall, I can cover up force and I get mass times acceleration. If I cover up mass, I get force divided by acceleration. And if I cover up acceleration, I get force divided by math. So you're going to be able to use this speed triangle in order to solve any of the problems you have around Newton's second law. So when solving problems, you're going to need to follow 4 steps. The first step is to write what you know, force, mass, and acceleration. The second thing you need to do is check your units. As I already told you, force is always measured in newtons, mass is always measured in kilograms, and acceleration is always in meters per second squared. The next piece can be a little bit more difficult, and I noticed that some of you struggled with this with the speed formulas. You need to choose which formula you want to use. So again, if you're looking for force, you just cover that up and it's mass times acceleration. If you're looking for acceleration, you cover that up and it's force divided by mass. And if you're looking for mass, you cover that up and it's force divided by acceleration. The last thing you're going to do is plug in the numbers and solve your problem. So what does this look like? Here's an example. The question is, what is the net force on a 2-kilogram skateboard accelerating at a rate of 2 meters per second squared? Well, what I'm going to do is I'm going to refer to my 4 rules here, and I'm going to follow them. So the first thing I need to do is write what I know. Okay, so I'm going to write down what I know, and I suggest that you do this on all of your problems. You can just write it down, FMA, force, mass, and acceleration. So force, right here in the question, it's telling us that they're asking for what is the net force. So what I can do is I could just go ahead and indicate that by a question mark. The next thing is mass. So when I go through here and I'm looking for the mass, well, I know that mass is in kilograms, and I just happen to have something right here that's in kilograms. So I know that my mass is equal to 2 kilograms. And finally, when it comes to acceleration, it tells me it's accelerating at a rate of 2 meters per second squared. Fantastic. So I've written everything down that I know. The next thing I'm going to do is I'm going to check my units, and I'm just going to double check my force. Well, I'm going to be looking for that, so I'll be looking for that in newtons. My mass is in kilograms, and my acceleration is in meters per second squared, so it's all good. Next thing I want to do is choose what formula I need. Well, I know that I'm looking for force, so I'm just going to cover up force, and I can see the force is equal to mass times acceleration. So I'm going to go ahead and use this problem right here, or this formula. Force is equal to mass times acceleration. Well, the next thing that tells me to do is just plug in my numbers. Well, my mass is 2 kilograms, and my acceleration is 2 meters per second squared. So plugging those in, this is what I get. I'm going to go ahead, solve, and this is where things can get a little bit tricky. Force, if I look at my units right here, I've got kilograms times meters per second squared, and that's all really pretty ugly. The nice thing that physicists have done is physicists, given the fact that we're always measuring our force in newtons, and we always have our mass in kilograms, and we always have our acceleration in meters per second squared, we can go ahead and just write that as 4 newtons. So a kilogram times meter per second squared is equal to a newton. And there you have your answer. Let's look at another practice problem. This one, what is the acceleration of a 750 kilogram horse using 1500 newtons? Well, as before, I'm going to write down what I know. Or actually, I'm going to show you all my rules. So I've got to write down what I know, and I'm going to go ahead and I'm just going to write force, mass, acceleration. You can write that as FMA. My force here in this problem is equal to 1500 newtons. Right here, that's where it states as 1500 newtons. My mass is given as 750 kilograms. And finally, my acceleration is the unknown piece. So I'm going to go back, I'm going to check all my units, forces in newtons, masses in kilograms, and acceleration is my unknown. So I'm going to go back over to my nifty triangle. I'm going to cover up acceleration, and I can see that acceleration is equal to force divided by mass. So I'm going to write that problem down. Acceleration is equal to force divided by mass. Now what I'm going to do is plug in my numbers. My acceleration is force divided by mass. So my force over here I've written down as 1500 newtons. My mass is 750 kilograms. And then I'm going to go ahead, plug in my numbers, and solve. And I end up getting acceleration is equal to 2 meters per second squared. Now, like before, we had these units that were a little funky, newtons divided by kilograms. But knowing that we always write our units the same way, force in newtons, mass in kilograms, acceleration in meters per second squared, I can go ahead and change this unit to meters per second squared, and there you have your number. Your challenge for class tomorrow, what I'd like you to do is write your own problem using Newton's second law. You can use the force triangle any way you want. You can write a problem calculating for force, for mass, or for acceleration.